Alright, this lesson has to do with the law of sines and cosines, but before we get into the law of sines and cosines, we're going to work with a new area formula for a triangle. Now, the area of a triangle is given by 1/2 of the product of the lengths of two sides times the sine of their included angle. So there's 3 variations to this formula depending on what side lengths and angles you have to work with. But for example, say I have B and I know what C is, or lowercase c. I know what lowercase b is and what lowercase c is. I know those 2 side lengths. And I also know the included angle. In other words, the angle made up by those 2 sides. All right, if I have that information, I can figure out the area of this triangle using this formula. And the same idea applies to these other 2 variations. All right, so for example, once it says find the area of the triangle, round your answer to the nearest tenth. Okay, so I have these 2 sides. So it's going to be the area is equal to 1/2. All right. The product of those side lengths times the sine of the included angle. What's the included angle? 135. All right. So you can just punch this in your calculator and we get 114.2 if we round to the nearest tenth. And we're working with just units in this case, squared. Alrighty, on to the next part. Here we have the law of sines. Now, when you initially look at the formula, it seems complicated. Let's break it down. It's actually very simple. Here I have the sine of angle A over length A is equal to sine of angle B over length B. Alright, that's your equation right there. You only use part of what we have here. All right, or you could do sine of angle B over length B is equal to sine of angle C over length C. All right, so you only use that. Or you could do this, sine of angle A over side length A is equal to sine of angle C over side length C. All right, or you could reverse everything and you'll still get the same result. All right, so let's apply this formula, see how it works out in a concrete example. We're going to solve the triangle, and solving the triangle means to find all the missing angle measures and side lengths. All right, so what do we have to work with here? All right, I have this angle to start with here, 115 degrees. I have the side across from it, that's 20. That would be my little a, or my lowercase a. And then I have this side length, 11 here. That's across from angle B. So this is the angle I want to solve for. Okay, just to be absolutely clear, this is what we're working with. We have sine of angle A over the length of A is equal to sine of angle B over the length of B. And here we have lowercase b. All right, so it's going to be sine of 115 degrees over 20 is equal to sine of B over 11. All right, I'll cross and multiply now. And I get 20 sine of B is equal to 11 sine of 115 degrees. Then I divide by 20. Now I have sine of B is equal to 11 sine of 115 degrees over 20. Okay, now I'm not quite done yet. How do you isolate the B? Well, we learned that in the previous lesson. We have to take the inverse sine of both sides of the equation. Okay, so if I do that, once again, let me just break it down. I'm going to write every step out. I'm going to take the inverse sine of both sides. So now I have measurement of angle B isolated. And then I need to figure out what this is equal to, which is 29.9 degrees, or approximately equal to. Now what are we going to do with that? Well, let's look back up here. I know this here is 29.9 degrees. So now I can solve for angle C. So let's do a little work on the left side here. I'm going to take measurement of angle C plus 115 plus 29.9, and that's equal to 180. So we subtract both of those from 180, and we get 35.1 degrees. All right, so I have that. I have the angles now. Let me go back down here. I have that angle. All right, so I have one last missing side to find. Okay. And I want you to make it a habit of always using the biggest angle. Okay? There's some reasons for doing this, but just if you make it a habit of using the biggest angle, you'll always end up getting the right answer. Okay, so I'm going to use sine of A, so sine of 115 over 20. And now I have C, or measurement of angle C, so I'm going to have sine of 35.1 over length C. All right, cross multiply now. And I have C sine of 115 is equal to 20 sine of 35.1. And I divide by sine of 115. All right, and for C, I end up with 12.7. All right, so I found all the missing angles and side lengths. Done. All right, done. On to the next idea. Here we have the law of cosines. All right, now looking at these formulas, it may be a little intimidating at first, but you've worked with the Pythagorean theorem, you've worked with trig functions. It's essentially like combining the two together. All right, so here we have all these variations for the law of cosines. This is standard form here, and then we have the alternative form. All right, well, how do you get the alternative form? You just move all these over, and then you divide by this part, and then you isolate the cosine of A, which is what we have right here. And you can do it for all the other variations. All right, now, one very important idea. Can't stress this idea enough because a lot of students will run into problems when working with the law of sines and law of cosines. So you want to use the law of cosines to find the largest angle measure. All right, after you've done that, only after you've done that, will you be able to apply the law of sines without any issues. All right, now we could go into depth of why issues arise when you don't use the largest angle, but for the time being, only use the largest angle when working with the law of sines, and you won't run into any issues. Just as a little side note, there's something called the ambiguous case, so we won't get into that right now, but just know to always use the largest angle when working with the law of sines. So before we apply the law of sines, we're going to use the law of cosines. So example 3 says, solve the triangle, round the decimal answers to the nearest tenth. Okay, so what do I have to work with here? This would be my A, this would be my C, and I have angle B. Okay, so look at what I have here. I have A, C, AC, and I have angle B. So I have all the information I need here to solve for side length B. So let's do that. So I have B squared is equal to 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34 degrees. All right, not too bad. Just take it step by step. So here I have 121 plus 196 minus 308 cosine of 34 degrees. Okay, now I'm going to have b squared is equal to 317 minus 308 cosine of 34 degrees. All right, I'm going to square root both sides to get the b by itself. All right, so it's not too bad. So I need to take the square root of 317 minus 308 cosine of 34 degrees. And if you're using a TI calculator, make sure this is all in parentheses. All right, so I end up with 7.9. All right, there's my B. So 7.9. All right, now I want to figure out the largest angle. All right, how do you do that? Well, let's look at all the side lengths. Which one is the largest? We have 14 here. So C is my largest angle, and we need to figure that out. So I'm going to do here is use this formula, all right, for cosine of C. So I could isolate C. So I have A now, which is 11, and I have B, which is, I just figured it out, 7.9, and then minus C, which is 14, all over 2 times AB, 11 times 7.9. Okay, so I'm going to figure out this portion on the right side here. So cosine of C is equal to, and I get negative 0.0724395857. Okay, now you want to use as many digits as possible. All right, because to isolate C now, I'm going to take the inverse cosine of both sides. Okay, so I've isolated C now. The inverse cosine essentially undoes the cosine. They're gone. And what do I get now? Let's plug this in the calculator. I get 94.2 degrees. Alrighty. Alright, if you're off a couple decimal places, I won't get crazy about that. Alright, the last angle we have to figure out is A. So measurement angle A plus 34 plus the angle that I just figured out, 94.2, is equal to 180. Okay, and I'll subtract both of those measurements from 180, and I get 51.8 degrees. All right, so it takes a little bit of work to get this done, but it's not that bad once you know what you're doing. All right, so if you have any questions, please let me know. Begin the assignment.